Hi, and welcome back. What I'd like to do today is to take a look at some of the concepts from 2.3 and 2.4, where we have different ways of measuring the center of a distribution or data set, and ways of measuring the spread of a distribution or data set. We'll talk about mean and median, a little bit about mode, and then standard deviation, the range. We'll talk a little bit about outliers and what we mean by a measure being resistant to outliers. We'll examine some histograms, talk a little bit about their shape, how to describe them. That's kind of a holdover from the last sections as well. We'll run through an example of how to calculate standard deviation, which is kind of a complicated calculation that you'll do once or twice by hand, and then we'll turn it over to software to do the rest of them for us, because it's kind of a pain, and once you understand how to do it, then we should turn that over to something that's better at calculating things than we are. All right, so I'm in StatCrunch. I'm going to open up the StatCrunch website. Looks like it's hanging up a little bit. Okay, and so I'm going to go to My Data. And this is where I'll find the examples that I'm going to go through today. So these are examples for 2.3 and 2.4. Let me click on that. So this is actually from an Excel spreadsheet that I'll post on Moodle. And I'll do something, the spreadsheet's a little bit different, and I'll do an example on the spreadsheet in a few minutes. All right, so for right now, what you're looking at here are made-up exam scores for 4 different exams and 30 students. Okay, so we've got exam 1, exam 2, exam 3, and exam 4, and I'm going to go through them. I'm going to create a histogram, or rather let StatCrunch create a histogram for each of them, and we'll talk a little bit about how to describe the shapes of those distributions. So let me go to Graph and Histogram. Now this is a useful feature down here, where if you click on these 2 boxes, you can get StatCrunch to display both the mean and the median on the histogram itself. The mean will be a green symbol and line, and the median will be a red symbol and line. And I'm going to go ahead and just tell it to do all 4 of these exams, and we'll click through them one at a time. So let me compute that, and let me center this on my screen and blow it up just a little. All right, so remember how a histogram is made. It selects bins. In this case, it looks like the bins have size 10 points. So the first bin would indicate anyone whose score was between a 50 inclusive and a 60 not inclusive. And it looks like 2 students scored between 50 and 60. And then 7 students scored between 60 and 70, 10 between 70 and 80, 8 between 80 and 90, and then there were 3 that were between 90 and 100 out of the fictitious 30 students here. So if you kind of step back a little bit, this histogram should appear to be roughly symmetric, because if you drew a vertical line down the center, it's roughly the same on both sides. Now, it doesn't have to be exactly symmetric for us to consider it to be symmetric. This one we would feel pretty good about calling symmetric. And it also appears to be sort of, as a general term, unimodal. So that means there's sort of one area in the histogram that appears to be the most frequently had score. And so it's not as specific as listing all the scores and looking for a mode. Unimodal for a histogram just means roughly there's one kind of bar that's clearly the most popular among the subjects. So One other thing that we want to look at when deciding whether a histogram is symmetric or not, and that is to compare the mean and the median. So notice that they're really, really close together here. That's a good indication of a symmetric distribution. It's not conclusive, but if you have something that looks fairly symmetric and the mean and the median are as close as they are here, roughly they're the same, then we'll go ahead and conclude that we have a symmetric distribution. There don't appear to be any outliers. All right, there are no colored bars that stand well apart from the rest of the distribution. We'll add an outlier in a moment to make a different point. So I'm going to go step through to exam 2. So just click here. All right, now this is a very different sort of result for the exam. It looks like it's unimodal, and that the most frequent bar or bin is the one between 80 and 90. So a lot of students scored in that range. But notice this one is not symmetric. It stretches much further to the left from the sort of center than it does to the right. Because of that, we would call this one skewed left or left skewed. Right? So maybe another way of thinking about skew is it's the stretch. Right? So we have sort of this kind of typical value with the really tall bars, and then it stretches further to the left than to the right, so it's left skewed. And you'll usually see that reflected also if you compare the mean and the median. Notice that the mean here is about 72 almost. The median is about 79. And so the mean has been pulled to the left of the median. It's smaller than the median because of the observations that are sort of far away from the central part, but to the left. So stretch to the left means left skew, and typically the mean will be to the left of the median. All right, let's look at exam 3. All right, so this is kind of the opposite situation where it's unimodal. We have one kind of most frequently obtained range of scores, that's between 40 and 50. It stretches much further to the right than it does to the left from that sort of central part. So we would say that this is right skewed because of the stretch to the right. And notice that the mean is about 59, which has been pulled to the right of the median, which is about 53 and a half. All right, so stretched to the right means right skewed. All right, now here's a histogram that it looks like we have a cluster of scores in the sort of 30 to 40 range and another cluster in the sort of 90 range, 80 to 100, somewhere in there. This one appears to be bimodal, right? So we have these sort of two pronounced clumps of scores, one in this, what we would call the F range and one sort of around the A range. But this is roughly symmetric. The mean and median are not identical, but they're very close. And if you draw sort of a vertical line right here, then the distribution is roughly the same on both sides. So we would call this roughly symmetric and bimodal. Now, if you were an instructor and got exam scores that looked like this, this would cause you to think a little bit about why it occurred, because like if you had, say, two different sections mixed up in the exams and it turned out that one section was over here making A's and the other section was over here making F's, that would indicate something likely was different about the two sections. So maybe you forgot to do a section, or there's some other reason for the difference in performance. But if you got scores like this, you would definitely want to investigate what exactly was going on there. All right, so let me exit out of the histogram. Just talk a little bit about looking at the measures of center and spread. I'm going to pull up the statistics for exam 1. So I go to Stat, Summary Stats, look in columns, pick exam 1, and let's see, I don't think I well, I won't mess with that. It's going to calculate some things I don't need, but that's okay. We could tell it not to, but let's just get to the example. All right, I'm going to center this. So what this is saying is that for exam 1, we had n equals 30 scores. The mean was about a 75.26. The standard deviation was about 11.29. That's a measure of how much variation there is between the scores and the mean. And then the median was a 75. Right? Remember, the median is the middle value. Let's check that one real quick. So I'm going to go over to the exam 1 column, click on the little arrow, and tell it to sort that column by ascending scores. So remember, to find the median, you have to put the scores in order first. And because I have 15 observations, that's an even number, and I would actually, the median would be the average of the 15th and 16th observation. So 75 plus 75 divided by 2 is exactly 75. And that's what the median is reflecting here when we let StatCrunch do it for us. This says that the smallest score is 51, that's the minimum. That's the first score once I've sorted them. And then the largest score is down here, that's a 95. And largest minus smallest, 95 minus 51, would be 44. And that's our other measure of spread. That's the range. All right, so I want to see what happens if I add an outlier to this exam. And so an outlier here might be, let's say, a student who made a 0 on the exam. So I'm going to enter that just by hand. And then under options, I'm going to redo this calculation, just refresh it with the new data point. And notice what happened. The mean went to 72.83. The median didn't change. The standard deviation went up by quite a bit. It went from like 12, I think it was, to about 17. And the range went from 44 to 95. So it looks like we have the median as a resistant measure because we added an outlier and it didn't change the value of the median. But the mean did change by quite a bit, and so did the standard deviation, and so did the range. So if I was going to summarize this, I would say that the resistant measures were the median, actually just one, and then non-resistant, the mean, standard deviation, and the range. And let's see, I can move this. Maybe I'll just click out of it for now. And I can increase the size of the column so we can actually see the list of the resistant and non-resistant measures. We didn't actually talk about the mode here, but the mode is typically a resistant measure as well, right? The mode is the most frequent measure, and so if you have an outlier, that shouldn't change the most frequent measure. Right. So let me go back. I'm going to delete the outlier for a second. Pull up the result that we just did, the summary stats for exam 1. All right, so when we had the outlier, the mean was about 72.8, the standard deviation about 17.5. Without the outlier, the mean's about 75.3, standard deviation about 11.3. So big changes with the presence or absence of that outlier. Same for the range. It went from 95 back down to 44. All right, so that's what we mean by resistant or non-resistant measures. And we've gone through the shapes of all the exam scores. So the last thing I wanted to do was say a little bit about the empirical rule. So the empirical rule says that about 68% of all of our data, if we have a roughly bell-shaped distribution, should be within 1 standard deviation of the mean. So let me pull up my results for the exam one more time, and also the histogram. Well, I'll hold off on that. All right, so the mean is about 75, the standard deviation is about 11. So the empirical rule says we should have 68% of our data, or thereabouts, within 1 standard deviation of the mean. So 75 plus 11 would be 86. That's the mean plus 1 standard deviation. The mean minus a standard deviation would be 75 minus 11. That would be about 64. So we ought to have about 68% of our data between 64 and 86. So over in the exam 1 column, I can count the number of data points that are not there. That's 1, 2, 3, 4 are less than 64. And 1, 2, 3, 4, 5, 6 are more than 64. So that's a total of 10. And if I get my calculator out, right, that means, well, it means that 20 of my data points are within 1 standard deviation. And if I do 20 divided by 30, of course, that's 2/3. So we have about 67% of the data points for exam 1 are within 1 standard deviation of the mean. And the rule of thumb says it ought to be about 68%. Now, that only works out for us because, let me pull the histogram up again. That only works because the histogram is roughly bell-shaped. And it's not exactly easy to tell that from this particular example, but it's unimodal and symmetric, and that's typically good enough. All right, now we could continue with the rule. We don't have enough data to expect it to be particularly good, but remember the rule says 95% of our data should be within 2 standard deviations of the mean, so that would be 75 plus 22 or 75 minus 22. And then we get virtually all of the data, 99.7%, within 3 standard deviations of the mean. All right, so that's what I wanted to do on StatCrunch. I'm going to pull up the data set that will be posted on Moodle. And I've added a little bit. I've got this exam 5, and I have this up here just to give an example of going through the calculation for the mean and also for standard deviation. All right, so you have the formulas in your notes, and there's a description of why the formula is as it is for standard deviation. It's a little bit of a complicated one. But let's go through the mean first. So we've got exam 5, we only have 5 scores. So the way to find the mean is to take the average. That means add them all up and then divide by, in this case, 5. So in Excel, if I want Excel to do a calculation, I just type the equal sign first, and then I can add 55, 70, 74, 80, 86. I'm just retyping the scores. That's 365. And then to get the mean, I would take, remember, equal sign first, 365, and divide it by 5. All right, so that 73 is the mean of the data set. That would be our X bar. And now if we wanted to get standard deviation, we have a series of steps we have to go through. First, we have to figure out how far every value is from the mean. So I take each data point and subtract the mean from it. So 55 minus 73, and then 70 minus 73, and then 74 minus 73, and then 80 minus 73, and then 86 minus 73, typing an equal sign first each time. And so here are all of my deviations from the mean. And one thing I wanted to point out that was claimed in the notes is that You can't just add up the deviations to get an idea of how far away the points are from the mean, because the deviations themselves always add up to 0. So minus 18 plus minus 3 is negative 21, plus 1 is negative 20, plus 7 is negative 13, plus 13 is 0. So in the formula for standard deviation, we always square the deviations from the mean to make sure that we get only positive numbers to deal with. So my squared deviations would be, let's see, minus 18. To square it in Excel, you use the little caret sign. That's the Shift-6 key. And then minus 3 squared. And then 1 squared. And then 7 squared. I know we can do some of these in our head. That's okay. And then 13 squared. And then we want the sum of all of those squared deviations. That's in the notation, that's the sigma of x minus x bar quantity squared. So that would be 324 plus 9 plus 49 plus 169. That's the sum of all the squared deviations. And now the average, when you're doing standard deviation, we have this sort of quirk where we don't divide by n, we divide by n minus 1. So in this case, we divide by 4. So the average of the squared deviations, understood to be dividing by n minus 1, is also known as the variance, or s squared. So we've got that as 137.75, and then the final step is to take the square root, which you can do in Excel with an SQRT, 137.75. And that is done, at least in part, to make sure that the units we're dealing with are back to the original unit. So here we're saying standard deviation of about 11.7. So in a sense, this is kind of the average departure of one of our individual exam scores from the average exam score. So about 11.7. All right, now as we saw with StatCrunch, it's much easier to get StatCrunch to do that for us. I'm going to check our work by copying this into StatCrunch. Let's see if this works. Kind of wasn't expecting it to, but it did. I just copied and pasted right into the column. Now I'll go to Stat, Summary Stats, Columns, Exam 5. And we did well. The mean is 73, the standard deviation 11.74, and that's what we found on our own, rounded of course. All right, so you've got a worksheet which will take you through the steps of doing something very similar in Excel to find a mean and standard deviation for a few more points. For those of you that like to do things more quickly, I'm going to run through this again, but I'm going to use the capabilities of Excel to do it faster. And this will come in very handy if you well, once you take a look at the worksheet, you might see why. So first off, you can get the sum of those 5 numbers in Excel just by going to Auto Sum. If you pull that down, you see there's a sum feature. And just hit return. It actually was adding what was in this cell as well, but that cell is empty, so it's no problem. And then if you want to deal with a number, you don't have to type the number again. You can just tell Excel by clicking on it which cell, in this case F8, the number resides in. Then divide it by 5. Up here, for deviations from the mean, we can take the exam score, which is in cell F2, and subtract the mean, which is 73. And then You can copy that formula down if you grab the bottom right corner of the cell, left click and drag. Then what it does is copy the formula so that it's taking all of the exams one at a time and subtracting the mean from them. And then our square deviations we can do in the same way. Take whatever's in that cell, square it, and then drag that down, and it'll square all of them for us right away. Go to Auto Sum to add them up. Don't worry about adding an additional empty cell. And then the average, here we'll take the result in that cell, divide it by 4. And finally the square root, as we did before, SQRT of the final result, and that's my 11.74. All right, so it's a little bit, it's okay if you're not comfortable doing some of the techniques in Excel. It'll make things a little easier on the worksheet, but it's not required. All right, so good luck on that, and I will see you soon.